get started with 5.1, which seems kind of like a random thing to throw in the middle of 8.4 and then 8.5. 8.5 is what we're going to do next. And in 8.5, you're going to learn more than you ever wanted to know about what are called rational functions, which are functions that have x's in the denominator. Okay? So the first thing in 8.5 that they're going to ask you about every rational function is what is the domain of the function, which means what can x be? What can you use to plug in for x? Now, when we're looking for that in a rational function, what we're actually looking for are what would be the restrictions for the x. What can x not be? Because once you know what x cannot be, then it can be anything else but that, okay? Now, remember, a rational expression is just a fancy way to say a fraction. And we've done this before. What makes a fraction undefined if the denominator is what? 0, right? The denominator of a fraction cannot be 0. So that's what 5.1 is just finding the number or numbers that make your rational expression undefined. So looking at number 1, it gives us a fraction, this rational expression, and it says for what number, find all numbers for which it's undefined. So when you're finding what makes a rational expression undefined, you don't really care about the numerator, right? Because any number could be in the numerator, including 0. But the denominator can't equal 0. So you just say, okay, I'm going to see what makes that equal 0 by setting it up as an equation and solving it for the c, which means I would just subtract that 21 from both sides. So now I just have the 5c can't equal negative 21 and divide it by 5. So c can't equal negative 21/5 because that's the number that would make that rational expression undefined. So the rational expression is not defined when c equals negative 21/5. Okay, number 2, same kind of thing, except now what's in the denominator has an x squared. So let's look at this one, which just means there's not only going to be one number that makes it undefined, there's going to be 2, right? Because almost every time you solve for an x squared, you get 2 solutions. Not 100% of the time, but almost all. The only way you would only get 1 solution is actually if you get 2 solutions, but they're the same number. Okay, but for what we're doing here, x squared minus x minus 1 over x squared minus 12x plus 35. So we're going to get 2 solutions here. Because still the denominator can't equal 0. And you're doing exactly what you're supposed to do. Because what are you doing when you're trying to find the answers to what does this make it? Quad. Right? So I can go straight to quad. Put in my A, B, and C. If I put in A is 1, B is negative 12, and C is 35. In my quad program in my calculator, what is it going to tell me? 7 and 5 are the values that x couldn't be. If you didn't have your quad, then the other method would be this factors down here. So I would have x and x for x squared. Factors of 35 that add to negative 12 would be negative 7 and negative 5, right? Multiplies to positive 35, adds to negative 12. But then what do you do with your factors when you're solving for quad equations? Set them equal to 0. That's what turns them in. When I solve them for the x's by adding 7s here, that's what gives me x equals 7 and adding 5s here to get x equals 5. So 7 and 5 are the values that make the expression undefined. Now, when we get into the rest of them, it's asking me to find the domain of the function. So the process is the same. We're still going to find the values that make the expression undefined, but then we're going to say x can be anything but that. Okay, so like on number 3, when your expression is f of x equals 5x minus 3, over x plus 5. Same thing. The denominator can't equal 0. So I'm going to solve it for x. Minus 5 minus 5. So x cannot equal negative 5. So it asks you to enter it in 2 separate ways. The set builder notation, which is this. So you're going to go find, and that one they give you multiple choice. Remember, you're not trying to find what x can equal, you're trying to find what x cannot equal. So make sure when you're doing the domain problems, you say x is a real number and x can't equal negative 5. Okay, then it's going to ask you to write it in interval notation on the second part of the answer. So when you're writing it in interval notation, remember interval notation's the ones that has the parentheses, the infinities, and things like that. So I want to say that x can be any number on the number line all the way from negative infinity to positive infinity, except that negative 5. So how would I say that? All the numbers below negative 5 would start at negative infinity, go to negative 5. So that takes care of this part. Then remember what we put in between. We put that U, that means in union with or and, all the numbers above negative 5. So negative 5 to positive infinity. Would be the interval notation. All right, number 4. So g of x equals 6 over 5x minus x squared. So on this one, again, the denominator can't equal 0. It is squad, right? Because it's x squared is my highest exponent. Just be careful when you're typing in your A, B, and C. Doesn't matter where the terms are, the A is what's in front of the squared term. What is in front of the squared term? Good, -1. Your B is what's in front of the X, which is 5. And your C is your constant. So this one doesn't have a constant, which means what's your C? So if you go to quad, so program down to quad. Type in your A, B, and C as -1, 5, and 0. Hit enter. So your two solutions would be 5 and 0. So that's what X cannot equal. So there's your set builder notation. Now, be careful when you're doing the interval notation. Now, I want to say all the numbers between -infinity and +infinity except for 5 and 0. When you're entering in set building notation, it doesn't matter the order of these numbers. But when you're entering in interval notation, it does, right? Because when you're talking about the number line, you can't put 5 there and 0 there, right? That doesn't make sense. When you're coming from -infinity, you're not going to run into 5 and then 0. What are you going to run into first? Right, you're going to run into the 0 first and then the 5. So this one will start at -infinity, go up to 0. This and between 0 and 5. That's why you can't put the 5 and the 0 in the other spots, right? Because you have to have this, when you're doing interval notation, this has to be the smallest number to the biggest number. So numbers between 0 and 5, and then and 5 to +infinity. Number 5, right there. So again, this section is really just warming you up for section 8.5 when we do all kinds of things with rational expressions. The first thing you're always going to do is find the domain of it. So this is just practicing for that. F of x equals 4x squared minus 71 over 3x plus 13. Am I going to quad for this? No, don't need to because I don't have an x squared. I'm just playing. I'm only going to get one solution here because I just have a plain x. So I'll subtract the 13. So 3x cannot equal -13. Divided by 3. So x cannot equal -13 thirds. Oh, and then so there's set builder, and then what about interval? From the bottom, -infinity to -13 thirds, and above -13 thirds. So 13 thirds to +infinity. Last one. F of x equals x cubed minus x squared plus x plus 4 over x squared plus 11x plus 28. Denominator can equal 0. This one is quad. So if I do go to quad and put in my A, B, and C as 1, 11, and 28. So again, just back to quad. A is 1, B is 11, C is 28. Enter. So your solutions to that are -4 and -7. Again, when you're doing set builder notation, it doesn't matter which of those numbers come first, but think about this, when you're on the number line, and you're at negative infinity, and you're traveling to positive infinity, who are you going to come up to first from the negative side? -7, right? It's more negative, which means it's less. So the -7 comes first, and then the -4. So here's your intervals, negative infinity to -7. And in between -7 and -4. And above -4. So -4 to positive infinity. So again, short and sweet, just practicing and getting ready for 8.5.